Heat is the form of energy which enter from one body to another body. Okay, no? Which having the difference in their temperatures, that it is heat. Then what is heat capacity? What is the heat? Already I told you children in the previous classes, right? Then what is heat capacity? Heat capacity. Before discussion of the heat capacity, let me take the one more example, this one. Now, in this beaker, what I am taking, children? In this beaker, I am taking the water for the example. Water, I took. H2O, I took. Of course, this water is existing with 25 degrees centigrade temperature. Is maintained in this water. Okay, by supplying some of heat, to this one. Okay, its temperature will be raised from 25 to 25 plus T degree centigrade temperature. This is the difference in temperature. Whatever the temperature should be raised, it is directly proportional to this heat, means Q, quantity of heat, is directly proportional to heat, temperature change. Temperature change, this term to be considered as delta T. So greater heat if you are supplied, heat difference will be greater, so that it may be related with each other. Q is directly proportional to change in temperature. Now here Q is equal to change in temperature into C. It's clear, children. Here C is heat capacity. Heat capacity. This equation is rearranged to C is equal to Q by delta T. Q upon delta T. It's clear. Now here C is heat capacity. Delta T is T2 minus T1. That it is a difference in temperature. Difference in temperature. Here Q is heat absorbed. Heat absorbed by the system. By the system. Right. So by using this one, we may frame the definition for the heat capacity. Now, heat capacity is the amount of heat is required. The amount of heat is required to rise this system or body or matter throughout the matter, by 1 degree C. Such amount of heat is required is said to be called as heat capacity. Children, once again I am repeating this. The amount of heat is required to rise the temperature of a system or body by 1 degree. That it is called as heat capacity. Heat capacity of system depends upon its internal structure and physical state. It's clear, right, children? Is anybody doubt? Is anybody? Amina, okay now? Amina. For the example, this is I am taking, for example, 100 ml or 100 grams of water. This is 100 grams of water. It is at 25 degrees centigrade temperature. Okay. This total water temperature to be raised to 20 degrees centigrade temperature. To raise the temperature of this water, we have to give some amount of heat or energy, such quantity of energy which is required to rise the temperature of a system by 1 degree centigrade temperature is called as heat capacity. Once again, I am repeating the amount of heat is required to rise the temperature of a system by 1 degree Celsius is called as heat capacity. Children, anybody doubt regarding this one?
No
No
doubt,
doubt.
sir.
Write down. The amount of heat is required. The amount of heat is required to rise the
Temperature by 1 degree Celsius.
heat is required to rise the temperature of a system or body by 1 degree C is called as is called heat capacity. Heat capacity of system. Children, okay, na? It's clear now.
Clear, sir.
Now heat capacity is this one. For heat capacity, this is a Q by delta T. Q is calories. Change in temperature degrees C inverse units. This is the discussion about the heat capacity. Of course, children, heat capacity at a constant temperature, heat capacity at constant pressure. So before discussion of that discussions, let me move to the another example. Concept that it is a specific heat capacity. Then what is the meaning of specific heat capacity, children? Let me discuss.
So scroll down the screen. I should write.
Specific heat capacity. Specific heat capacity. Then children, what is a specific heat capacity? How it is related with heat capacity? Let me discuss now. Now, specific heat capacity means the amount of heat is required to rise the temperature of a system, okay, no? Of 1 gram of substance by 1 degree. Here, mass is not fixed here in this case. But here, mass is fixed. Mass is fixed. For the example, this is water. This is water. Just what I am taking, children? 1 gram of water. It is exist with just 25 degrees C centigrade temperature. Okay. To rise its temperature from 25 to 26 means difference is 1 degree. So, how much amount of heat is supplied to this one? How much amount of heat is supplied to this one is called as specific heat capacity. Right, children. Specific heat capacity means the amount of heat is required to rise the temperature of 1 gram of substance by 1 degree is called as specific heat capacity. Right? The amount of heat is required to rise the temperature of 1 gram of substance. 1 gram of substance by 1 degree C by 1 degree C, which is called as a specific heat capacity. This is called as specific heat capacity. Specific heat capacity. Specific heat capacity. It's clear, na children?
Clear, sir.
Right. Now, once again, I am repeating this one. The amount of heat is required to rise the temperature of 1 gram of substance by 1 degree is called as specific heat capacity. Now, Q is equal to, okay, S into M into delta T. Now, here M is mass of substance. Mass of substance. S is a specific heat capacity. Specific heat capacity. Now, delta T is already we know
Change in temperature.
Q is absorbed heat. Right, children? This is a specific heat capacity. S equals to Q upon M into delta T. Simply, specific heat capacity is equal to, this part is considered as heat capacity, no? Heat capacity upon mass of substance. It's clear now?
Yes, sir.
Right. So if you consider that S is equal to Q upon M delta T. For Q is, for example, I am taking joules. Okay. Mass is in a gram inverse and temperature is Kelvin inverse, is units. Now, this is if I am taking calories per joules. This is a gram inverse and Kelvin inverse. Now, calories energy, grams mass, and degree C is inverse. Children, it's clear now? Units per specific heat capacity. Calories, gram inverse, okay, centigrade inverse by this equation. It's clear now, children?
Clear, sir.
Yes, sir.
Yes,
Sir, then what is joule, gram, kilo?
Joule, gram inverse, Kelvin inverse. This is heat is in joules. If you are supplied heat measured in joules, this is a mass of the substance if you are taken in grams. Now temperature if you are measured in kelvins, then joule upon gram, okay, Kelvin. So it is giving the same. Roger, clear?
Yes, sir.
Right. Now let me move to another concept. Copy now, children.
Yes.
Sir.
Shamla is present, is absent. Madam? Banu Shamla వచ్చిందారా? Now let me discuss about the molar heat capacity. Molar heat capacity. Then what is the molar? Numerical we will discuss in the next classes. I will explain the numericals, how to solve the heat capacity, molar heat capacity, specific heat capacity. Those all discussions will be in the next classes. Molar heat capacity. Now I am taking, children, this is 1 mole of water. First, mass is irrespective. What amount of mass is irrespective heat capacity. Mass is specified by 1 gram specific heat capacity. Mass is specified for molecular weight is molar heat capacity. Simple definitions. Now, this is the water at 299 Kelvin temperature. This is 18 grams of water, means 1 mole. 1 mole. Okay. Now, to rise this temperature from 299 to 300 kelvins, means 1 degree C. Rise and difference in temperature is 1 degree C or 1 Kelvin. Of course, children. Now, this is then we have to supply some amount of heat to this one. Such a amount of heat is required to rise this temperature by 1 degree per 1 mole is called as a molar heat capacity. So children, once again I am repeating the statement that it is the amount of heat is required to rise the temperature of 1 mole of substance by 1 degree is called as molar heat capacity. This is a Cm. Okay, molar heat capacity. Right, children. The amount of heat, amount or quantity, amount of heat is required to rise the temperature of okay, 1 mole of substance by 1 degree or 1 degree Celsius is called as okay, no? This is called as molar heat capacity.
Sir, in the above formula, sir, specific heat capacity. Sir, their mass is already we know now, sir, 1 gram.
That it is specific heat capacity.
Yes,
If you are yes, so for the convenience, every time 18 degrees ki 28 degrees ki అని particular గా express చేయకుండా 1 mole కి express చేస్తున్నాడు.
No, sir.
Okay.
Specific heat capacity formula, sir. Sir, there, in the denominator is there as mass, no, sir. Can we take it as 1, sir?
1 gram, that it is specific heat. Specific heat capacity becomes as a more heat capacity. Clear? Okay, now mass is if you are taking mass is 1 gram and something by 1. Appudu emavutadi heat capacity equals to specific heat capacity. When you are taking the mass is 1 gram. If mass is not taken in the one particular amount, that becomes as this one. It's clear. So heat capacity is equal, molar heat capacity is equal specific heat capacity into molecular weight. For the example, specific heat capacity of water 4.18 joule, okay, na? Kelvin inverse, gram inverse. So its molecular weight is 18, is equal to 18 into 4.18 for the example. Varshit, understand the concept?
Sir,
Varshit.
sir, my doubt was different, sir.
Ma?
Sir, my doubt is not that, sir.
Normal, this is not this one.
Sir, my doubt is that there in the specific heat capacity, sir.
What is your doubt?
కింద మాస్ అని ఉంటే ఆ మాస్ ఆల్వేస్ 1 గ్రామే ఉంటుందని ఉంది కదా సార్ డెఫినేషన్.
అవును, yes. అంటే ఇక్కడ ఏమంటున్నాం కదా, హీట్ కెపాసిటీ ఇస్ మల్టిప్లైడ్ బై మాస్, ఇట్ విల్ బి గెటింగ్ ద హీట్ కెపాసిటీ. హీట్ కెపాసిటీ x గ్రామ్స్ ఉంది కదా, x grams కి ఇక్కడ మాస్ ఎన్ని గ్రామ్స్ ఉంది 2 grams ఉంది అనుకున్నాను. ఇట్ విల్ బి చేంజ్డ్ టు దిస్ వన్. ఇక్కడ x గ్రామ్స్ అనే ఎంతో మనకి తెలియదు మాస్. ఇన్ ద ఫస్ట్ కేస్ వాట్ డిడ్ వి డిస్కస్? సో హీట్ కెపాసిటీ వీ డోంట్ నో, 10 grams తీసేసుకుందాం. ఓకేనా, 10 grams ఉంది కదా. వాట్ ఈస్ ద హీట్ కెపాసిటీ? ఫర్ ఎగ్జాంపుల్ x అనుకుందాం. x, ఓకేనా, హీట్ కెపాసిటీ ఈజ్ x for 10 grams. Specific heat capacity is x by 10. 10 grams కే కదా అది వచ్చింది. అంటే 1 gram కే కదా ఇది వచ్చేది. ఇప్పుడు 10 grams gives x. 1 grams gives how much? 10 by x.
Okay, sir.
For 1 gram is considered as a specific heat capacity. So 10 x by 10. So that x by 10 mass. It's clear now, Arshit? It's clear your doubt?
Yes, sir.
So I am explaining once again, for example. Okay, if ఇక్కడ చూద్దాం మనం, ఇక్కడ ఎన్ని గ్రామ్స్ ఉన్నానా? 10 grams. ఫర్ ఎగ్జాంపుల్ 10 grams తీసుకుంటున్నాను. సో ఫర్ ఐ ఆమ్ టేకింగ్ దిస్ ఇస్ 10 grams ఆఫ్ వాటర్ కి నాకు 1.8 ఓకేనా జౌల్స్ ఆఫ్ హీట్ ఈజ్ రిక్వైర్డ్. సో ఇక్కడ ఏమనుకుంటాం నాన్న మనం? హీట్ బై ఓకేనా చేంజ్ ఇన్ టెంపరేచర్ ఆఫ్ కోర్స్ తీసేసుకున్నాం. 1 gram కావాలి. ఇప్పుడు మనకి 48 అనేది ఎన్ని గ్రామ్స్ కి? 10 grams కి. అంటే మాస్ ఇర్రెస్పెక్టివ్ that it is called as a heat capacity. We don't know what is the heat capacity. How much? 41 point. Any grams ki? 10 grams ki 41.8. 1 gram ki how much? 41.8 by 10 is equal to 4.18. Okay, na? If 4.18 our specific heat capacity. Specific heat capacity is 4.18. Clear now?
Yes, sir. Now I understand.
Thank you. Right, children, this is molar heat capacity. Then molar heat capacities are two different types. This is molar heat capacity. I explained you children for the example what I am taking. Specific heat capacity of water is 4.18 consideration joules. Now what is its molar heat capacity? Multiplied with this one. X gram ki ichadu anukunnanu. X grams ki ichadu. 2 grams ki ichadu. Molar heat specific heat 2 grams ki ichadu. Molar heat capacity kavali. Then what we will do? Multiplied by molecular weight. Specific heat is multiplied by molecular weight. You get the molar heat capacity. It's clear now? Children, it's clear.
Yes, sir. Yes, sir.
Right. Now, let me discuss about the molar heat capacity. Molar heat capacity is ఇక్కడ చూడండి తల్లి, మనం ఇందాక ఏమనుకున్నాం నాన్న? హీట్ స్పెసిఫిక్ హీట్ కెపాసిటీ ఇస్ హీట్ కెపాసిటీ బై మాస్. హీట్ కెపాసిటీ బై మాస్ ఇన్ స్పెసిఫిక్ హీట్ కెపాసిటీ. ఇన్ కేస్ ఆఫ్ molar heat capacity, molar heat capacity.
Specific by moles, sir.
Heat capacity is a heat capacity of what? Heat capacity upon number of moles. Number of moles. That it is C upon N. Now is equal to Cm. ఇక్కడ చూడండి, నెంబర్ ఆఫ్ మోల్స్ మీకు మోలార్ హీట్ కెపాసిటీ ఇచ్చాడు, నెంబర్ ఆఫ్ మోల్స్ ఇచ్చాడు. అంటే వెయిట్ ఇస్తే నౌ హియర్ n is equal to weight by molecular weight. వెయిట్ అపాన్ మాలిక్యులర్ వెయిట్. ఇటు వస్తే మళ్ళీ ఏమైంది? ఇన్వర్స్ వాల్యూ అవుతుంది, రిమైండర్. అన్ని రిలేషన్స్ మోలార్ హీట్ కెపాసిటీ ఇచ్చాడు, వెయిట్ ఇచ్చాడు, హీట్ కెపాసిటీని ఫైండ్ అవుట్ చేయమన్నాడు. ఈజీగా మాలిక్యులర్ వెయిట్ తెలుసు, వెయిట్ ని చేయమన్నాడు, 10 grams ఫైండ్ అవుట్ చేయమన్నాడు. 10 grams కు 20 grams కు ఈజీగా బై యూజింగ్ దిస్ వన్ we can solve this problem. Okay, then heat capacity C is equal to okay na molar heat capacity to number of moles. Then Cm is equal to okay C upon N. C is equal to N into molar heat capacity. Banu, it's clear na talli? Ma.
Yes, sir.
Sir, once more you explain it, sir.
Now, this is the number of moles, no? From the definition, molar heat capacity is equal to heat capacity upon number of moles. Means it may be noted that Cm is equal to, okay, Q into by N into delta T. This is Q by T is considered as C. This is number of moles. So C by N. C is a heat capacity, M is molar heat capacity. So heat capacity is equal to molar heat capacity multiplied by N. N. N is equal to, already we know that N is equal to weight upon molecular weight. It's clear. Make molecular weight to weight ఏదో ఒకటి ఇచ్చి క్రిటికల్ గా ప్రాబ్లమ్ ని సాల్వ్ చేయమంటాడు. ఇట్స్ వెరీ ఈజీ సాల్వింగ్ ఆఫ్ ప్రాబ్లమ్. ఎజంప్షన్స్ తీసుకోవాలి. చిల్డ్రన్, ఇట్స్ క్లియర్ నా?
Sir,
Clear, sir.
in that formula 18 is there, sir.
18 for water.
Okay, sir.
Okay na? Right. Just 1 second. No? Right. Now, heat capacities are two different types. Heat capacity. At two different types. Heat capacity at constant volume. Heat capacity at a constant volume. C, base V. This is also you can see molar heat capacity aina ide formula, no change. Now, heat capacity
At constant pressure.
at constant pressure. Heat capacity at a constant pressure. This is a Cp. Now, what is a Cv? What is a Cp? Let me discuss. Now, later, enthalpy ante ento maniki tarvata vastundalli. Later we will discuss about this one. Okay, దాని నుంచే మనం తెచ్చేసుకుందాం. Now, heat capacity at constant pressure and constant volume. Before going to this one, I am checking this one. Heat capacity at a isothermal process. Observe children, heat capacity is isothermal process. Isothermal process, change in temperature, dT is equal to 0. Heat capacity, okay, C is equal to Q by delta T. So delta T is equal to 0 by going to infinity. Now, heat capacity for adiabatic process. But already we know, children, for adiabatic process, change in Q is equal to 0. Now, heat capacity C is equal to 0 by change in temperature becomes 0. That means the heat capacity of system, either isothermal or adiabatic, in between 0 to infinity. Any value is possible. It's clear now? And the process is isothermal cheppanu. Okay, no? Next adiabatic condition cheppanu. Now, this heat capacity at an isochoric process, volume is constant. Heat capacity at a isobaric process, pressure constant. Simply it may be say like this: heat capacity at a Isochoric process means CV. Heat capacity at a isobaric process means pressure is constant, Cp. Right. How to get these values? What are the interrelates with each other? Let me discuss them. Now we know that just one second. H is equal to E plus PV. Later we will learn about this one. This is enthalpy. Then what is the enthalpy? Internal energy, already we learn about this one. Now enthalpy, then what is enthalpy? Enthalpy means the heat contained by a body at constant pressure. So that దాని explanation తీసుకోవడం కోసం ఓకే మనం ఎంథాల్పీని తీసేసుకుంటాం. లేటర్ వి విల్ డిస్కస్ అబౌట్ ద ఎంథాల్పీ. సో ఫస్ట్ ఎంథాల్పీ నుంచి వెళ్తున్నాను ప్రాబ్లమ్కి. రైట్ చిల్డ్రన్. నౌ ఎట్ కాన్స్టెంట్ వాల్యూమ్ CV. CV is equal to change in temperature. A small little bit amount of energy, కొంచెమే ఎనర్జీ ఇచ్చారు, అంటే 0.01 joules ఇచ్చారు. Okay, a little bit of amount of heat or energy is supplied, that it is considered as dQ. That it is, and the same heat change is also very little bit amount. So dt. Okay, no? These two are at a constant value B. But we know children, at constant value, change in heat change. At constant value, heat change is called as change in internal energy. So CV is equal to change in internal energy du by dt at constant volume. Now du may write like this: CV is equal to dE by dt at constant volume. dE is equal to means du. dE anna du anna okate. Now du is equal to CV dt. CV dt. If n moles తీసుకున్నాం అనుకున్నాను, NCV dt. This is for 1 mole. N mole ki consider చేస్తే NCV dt. It's clear. CV delta T, N delta T. It's clear. Children understand?
Once again you explain.
Now observe this one. The process is going at a constant volume. Volume is constant, so that heat contained by the body at constant volume is considered as internal energy U. Constant volume లో దాంట్లో ఉన్న హీట్ ని ఏమంటున్నాం మనము U అంటున్నాం. By absorbing the energy or heat, change from U1 to U2. By absorbing heat, then the difference between these two is considered as a delta U. By absorbing the heat, ఇక్కడ ఏం తీసుకుంటున్నాం మనం ఒక సిస్టమ్ తీసేసుకున్నాం. ఫర్ ఎగ్జాంపుల్ వాటర్ తీసేసుకున్నాను. వాటర్ C is equal to అనుకున్నాం. పర్టికులర్ టెంపరేచర్ ఎంత ఉందో అంటే 25 degrees సెంటిగ్రేడ్ టెంపరేచర్ ఉంది. ఓకేనా, దీనికి మన హీట్ ఏమీ లేదు. ఇప్పుడు నేను ఏం చేస్తున్నా, కాన్స్టెంట్ వాల్యూమ్ లో ఎక్స్పెరిమెంట్ కండక్ట్ చేస్తున్నా. కాన్స్టెంట్ వాల్యూమ్ లో, ఈ కాన్స్టెంట్ వాల్యూమ్ లో దీనికి 100 జౌల్స్ ఇచ్చారు. దీని దీన్ని ఇంటర్నల్ ఎనర్జీ ఏదో కొంత సమ్వాట్ ఇంక్రీజ్ అవుతుందా అవదా చెప్పండి. ఇంటర్నల్ ఎనర్జీ ఇంక్రీజ్ అవుతుందా అవదా? బయట నువ్వే ఉన్నావు, నువ్వు ఎనర్జీని తీసుకుంటే నీ ఎనర్జీ ఇంక్రీజ్ అవుతుందా అవదా? టెల్ మీ చిల్డ్రన్.
Yes, sir.
Yes, increases. So increased energy is final position U2. So initial మనం తీసుకుంది U1. The change in difference is considered as du. Initially 25 degrees centigrade temperature. After absorbing the 100 joules, its temperature may be changed to 26 degrees C or whatever, or 28 or whatever. The difference is considered as delta T. Now delta U upon delta T, delta U upon delta T. So delta U is equal to CV dt, cross multiplication. Is anybody doubt, children?
Clear, sir.
హీట్ కెపాసిటీ అట్ కాన్స్టెంట్ ప్రెషర్ డైరెక్ట్ గా వెళ్ళిపోతున్నా అంటే మీరు ఇంకా వర్క్ డన్ నుంచి చేయొచ్చు, అది మనకి నీటిలో లేదు, టైం వేస్టింగ్ ప్రాసెస్. సో ఆల్రెడీ వీ నో కాన్స్టెంట్ ప్రెషర్ ఈజ్ ఈక్వల్ టు heat absorbed, little bit heat is absorbed at a constant pressure by change in temperature. Already we know that this is right like this, dq by dt at P. Next, write like this, children. Now Cp is equal to, already we know that change in enthalpy means heat change at constant pressure is called as enthalpy change. Later you will learn, next question, that it is Cp is equal to dH by dt. Now dH is equal to Cp dt. Clear now?
Yes, sir.
Right. Now the relation between heat capacity at a constant pressure and heat capacity at a constant volume. Right.
Cp minus Cv equal to R.
Cp minus Cv is equal to
R.
R. Very good. Ma'am.
Sir, what does H represent, sir? Heat absorbed.
Enthalpy. H represents enthalpy. Later I will explain. After this terminology, I will go into the delta H. H ki helpothunnaanu. Wait, you will observe. That's why I am telling this is enthalpy. Next I will explain this one. Now Cp and Cv. So according to enthalpy definition, H is equal to U plus PV. We know that. Now H is equal to U plus PV. But you know that H is equal to U plus nRT. We know that PV is equal to nRT. It's clear. Now differentiate చేస్తున్నా తల్లి నేను for 1 mole అనుకున్నాం అనుకో 1 mole తీసుకున్నాం. If n is equal to 1 mole అనుకోండి. So H is equal to U plus RT. Now change its representation and integrated with okay na change delta H is equal to delta U plus R constant దీన్ని టీన్ చేసేస్తున్నాం మనం. ఓకే, R by R constant delta T. This is equation 1. This equation is divided by equation 1 divided by dt. Now delta H means dH. dH upon dt is equal to du by dt. Now plus R dt by dt. Now observe children, this is dH by dt is equal to Cp. du by dt is equal to Cv. dt cancel plus R. Right children. Cp minus Cv is equal to R. Okay. Now Cv is equal to Cp minus R. It's clear, children. Now, let me discuss about the one more thing is here. Now, Cp by Cv is equal to gamma. So, gamma is the ratio between Cp and Cv. Means heat capacity at a constant pressure and heat capacity of constant volume is taken as gamma. Children, still now it's clear, Nama? ఇప్పటి వరకు ఇంకెవరికైనా
Yes,
doubts
sir,
ఉన్నాయా?
clear.
The capital R and small are same, sir.
Ma'am?
Capital R and small are both the same, sir.
So if you are, this is not R, this is gamma. What I am telling, this is gamma.
Okay, sir.
This is gamma. Right. So first you have to learn about the monoatomic gas. Monoatomic gas. Then what is monoatomic gas? Monoatomic gas means atomicity is one. Atomicity is one means example helium, neon, argon,
Krypton.
krypton, and radon. Now, diatomic gases. Diatomic gases means atomicity of gas is 2. 2 means 2 atoms are present in the molecule. That it is H2, N2, O2, Cl2, okay, F2, etc. These all are examples for diatomic gases. And poly or tri. Poly or triatomic gases is O3 is the better example. Right, children. Now, degree of freedom, and if this is the gaseous, this is the degree of freedom is the characteristics of gaseous element, children. Degree of freedom, which is denoted by F. ఇంకా దానికి అంటే ఇక్కడ ఒక ఎగ్జాంపుల్ తీసేసుకుంటున్నాను నేను. దీనికి మనకి నీటిలో ఎక్కువ సిలబస్ లేదు, కానీ నీటిలో క్వశ్చన్ అడిగే సిలబస్ కి రిలేటెడ్ గా మనం బ్యాక్ సైడ్ కి వెళ్తున్నాం. బ్యాక్ సైడ్ మీన్స్ ఇట్ ఈస్ కాన్సెప్ట్ బేస్డ్ కి వెళ్తున్నాం మనం. అంటే కాన్సెప్ట్ బేస్ కి వెళ్ళిపోతున్నాం అక్కడ. అంటే ఇది రిమైండ్ అవ్వాలి అంటే మనకి కావాల్సిన నీట్ పాయింట్ రావాలి అంటే కొంచెం బ్యాక్గ్రౌండ్ డిస్కషన్ ఈజ్ ఇంపార్టెంట్. దట్ ఐ ఆమ్ డిస్కసింగ్. Right, children? So here F is a degree of freedom for gas. Okay, children. Degree of freedom means already we know that what is degree of freedom. Already I told you now. Degree of freedom means it is the characteristic property of gas. Okay, then gas may depend on it. Okay, right, children. Now, for monoatomic gases, for diatomic gases, for poly or triatomic gases. Right, children. For monoatomic gases, degree of freedom is 3, degree of freedom is 5, degree of freedom is 6. Characteristic properties of gas. Now, I am giving the children, this is a Cv, this is a Cp, this is a gamma. Not R, this is gamma. Right, children? Cv is equal to degree of freedom upon 2 into R. R means universal gas constant. Already I told you. So that Cv is equal to F. F is equal to, okay, no? This is the degree of freedom. And 3 kada anukunnam. So 3/2 R. Cv is equal to 3/2
So you mean
R.
the degree of freedom, sir?
It is the characteristic property of the gas. ఇది మనకి అసలు సిలబస్ లో లేదు. మిమ్మల్ని ఇది అడుగుతాడు. Cv for monoatomic gas అంటే 3/2 into R సార్ నేను 3/2 R అంటే ఇది ఎలా వచ్చింది సార్ అంటారు. సో ఇట్ కెన్ బి derived ఫ్రమ్ ద డెరివేషన్ బ్యాక్ సైడ్ ఉంది. F is degree of freedom, it is a characteristic property of the gas. ఇది మళ్ళీ వేరే దానికి లింక్ ఉంది. మనకి అంత అంటే ఉన్న సఫిషియంట్ టైం కి మనం ఇక్కడి నుంచి ఇక్కడికి రావడమే, ఇంకా ఇక్కడి నుంచి ఇంకా బ్యాక్ వెళ్ళడం టైం వేస్ట్. సో దట్ ఇస్ that's why I'm simply explaining F is degree of freedom of the gas. Later I will, okay, F means it is depends upon the nature of gas. For monoatomic gases is 3, for di is 5, for tri is 6. Right, children? Now F value I substituted for monoatomic gases. For diatomic gases 5/2 R. For triatomic gases 3R. Clear now?
Yes, sir.
Right. 6/2 is equal to 3R. Children, let me observe this one. So Cp is equal to Cv plus R. Cv plus R. Now Cv is 3/2 into R plus R. And taking the LCM value is 5/2 R. 5/2 R. Next for this one, Cp. Cv is equal to how much ma? 5/2 R. Okay, 5/2 R plus R. Okay. And solving this one, 7/2 R. 7/2 R. Now this is a 3R plus R. 3R plus R is 4R. This is a 4R.
Sir,
Plus R. No.
sir, can we write for Cp formula as 5/2 plus 1R?
This one, no? This is the value. This is the value of Cv.
No, sir. I'm asking that can we keep formula for a Cp as F/2 plus 1R?
This one, no?
F/2 plus 1R.
Yes. This is F/2. Okay, now F/2 R only, not plus R. F/2 into R. Now this is Cv. Na Cp is equal to Cv. Cv is how much ma? 3/2. 3/2 R plus R is there now in the formula. Plus R. Okay now. Understand na?
Yes, sir.
Is this I am taking the Cv value. Cv value is 3/2 R plus in the formula Cp is equal to Cv plus R. Okay. So ఇది కూడా ఎలా నోట్ చేస్తున్నాం మనం 3R ఉంది కదా. 3R plus R. 3R plus R is equal to 4R. That's why I am taking the 4R. Now Cp by Cv is equal to gamma. Cp upon Cv. So Cp ఏం వచ్చిందని మనకి ఇక్కడ Cp for the example, Cp for this one 5/2R. 5/2R upon 3/2R. 3/2R. By 2R cancel. Inverse value that it is direct value that it is 5/3. 5/3 is equal to 1.66. It's clear na? ఇప్పుడు నాకు కావాల్సింది ఇది కావాలి నాకు. For monoatomic gases, gamma is 1.66. This is important for NEET. ఈ పాయింట్ కోసం నేను ఇదంతా డిస్కషన్ తీసుకొచ్చాను. మిడిల్ లోకి వచ్చి వేస్తా ఉంటారు సార్ 1.66 ఎలా వచ్చింది. దట్స్ వై ఐఎమ్ సాల్వ్ టోటల్ ఇంకా బ్యాక్ వెళ్తున్నాను. ఇంకా బ్యాక్ వెళ్తే ఇంకా డిలే అవుతుంది. రైట్ చేయండి. దిస్ ఇస్ gamma for Cp by Cv. Cp value is how much more for diatomic gases? 7/2R. 7/2R by, okay, this is a 5/2R. 5/2R. 2R cancel. 7/5 is equal to 1.0. It's clear. Now next gamma is equal for triatomic gases. 4R, 3R.
1.30.
RR cancel. This is 1.33. What did you reminder or observe here? Has increased the atomicity of gas. Has increased the atomicity of gas. Its gamma value will be decreased. So gamma is inversely proportional to atomicity of gas. It's clear now?
Clear, sir.
Yes, sir.
Right, children. This is clear. Satvika? Satvika. Clear now?
Clear, sir.
Right, children. Moving to the next. Right. Now, I would like to explain that it is enthalpy. Children, ikkada variki manaki thermodynamics part lo unnam. Ikkada nunchi thermochemistry ki elli thermochemistry complete ga read chesesi, then after we will become to thermodynamics. Ante ikkade thermodynamics ni complete cheseyochu, but enthalpy chadavakunda thermodynamics second like velte dan meaningless untadi. That's why I am completing the thermochemistry. Thermochemistry is related with enthalpy. Right. Now, enthalpy. Enthalpy. Then what is the meaning of enthalpy? Asli enthalpy ane term ni manam enduku introduce chesukovalsi vachindi. Why the introducing the enthalpy? The term enthalpy. Why? Because children, most important need regularly question. Thermochemistry 1 question, thermodynamics 1 question. 2 questions from chemical thermodynamics. This lesson regular check cheskondi 2 questions unde. Right, children. Now, why we are using the term or introducing the term? This is the enthalpy. Enthalpy means to warm or to heat. Enthalpy means to heat or to warm. To warm. Okay, it's clear, children. Now, what is the meaning of to heat? To heat, enthalpy. Most of the reactions in the universe, most of reactions in universe takes place in open vessel or open system. But only little bit are with a closed system. Closed system, very little bit that it is useful. Most of the reactions are takes place at open vessel or open system. But we know heat exchanges at a closed system means heat contained by a body at a constant volume. Constant volume means volume is constant, means closed vessel. That it is called as internal energy. But what about the open vessels? For open vessels, pressure is constant. What about this one? But మనకి కావాల్సిన maximum కే thermodynamics related లేదు. That's way that a term is introduced, that enthalpy. Now, enthalpy means the heat contained by a body or system. The heat of a system. At a constant pressure, that it is called as enthalpy, denoted by H. Now, H is a state function, and an extensive property. What is the meaning of extensive property?
Depends on mass of a substance.
Depends upon the mass or volume or quantity. Right, children? Now, so the mathematical expression of the enthalpy. Before going to that one, state function, extensive property. So it cannot be determined directly. It cannot be determined directly, but its change can be calculated. It cannot determine it directly, so that it cannot be determinate directly, but the change in enthalpy can be determined. So that change in enthalpy delta H is equal to H final minus H initial, or change in enthalpy delta H is equal to H second stage final stage minus H1. Delta H is equal to, in case of chemical reaction, H product minus H reactant. Most important formula for NEET. Clear? Right, children. So mathematical expression of enthalpy is H is equal to U plus PV. H is equal to U plus PV. So based on this expression, we may frame the definition for this one. So that enthalpy is sum of internal energy and the product of pressure and volume. Is called as enthalpy. So in ఇక్కడ వచ్చేసింది కదా pressure and volume. That's enough. It's clear. Now we know that PV is equal to nRT. Then differentiate is creation. Delta H is equal to delta U. So ikkada H is equal to U plus nRT. Was it clear now? H is equal to U plus differentiation. Delta H is equal to delta U plus delta nRT. Most useful formula for NEET. It's clear. Now, delta H minus delta U is equal to delta nRT. Most useful formula. Difference adugtadu. Calculate the difference between heat change at constant pressure, heat change at constant volume is delta nRT. Then what is delta N? Let me discuss. Delta N means for a chemical process. Delta N is a number of moles of gaseous products minus number of moles of gaseous reactants. Right, children, this is the important one. Now, delta N is equal to number of moles of gaseous products, N gaseous product minus number of moles of only gases, not solid, not liquid. Now, reactant. So this difference may or may not equals to zero value. Based on this concept, the relation between enthalpy and internal energy we may assess. Right, children? Clear now? It's clear.
Yes, sir, clear.
Yes, sir.
Relation between delta H and delta U. Right. Now, let me discuss it. Case 1. Case 1. Whenever delta N is equal to 0. Delta N ఏమవచ్చునా మనకి 0 అవ్వచ్చు. Less than 0 అవ్వచ్చు. Greater than 0 అయినా అవ్వచ్చు. How? Let me solve this one. Delta N is equal to 0. Delta N is greater than 0. Less than 0. Just 1 second. More examples. I am taking the one more example for this one. Okay. H2 plus I2 gives rise to HI. Gaseous. Observe, children, for this one. Okay. This is 1 mole of hydrogen, 1 mole of iodine, 2 moles of gaseous HI. Delta N is equal to 2 minus 1 plus 1, 2 is equal to 0. For this reaction, delta H is equal to delta U plus 0 into RT. Okay, this total term becomes as 0. Then delta H is equal to delta U. Clear now?
Yes, sir. Yes.
Right. I am taking the one more example for this. Case 2. Case 2. Whenever delta N is greater than 0, what we have to take? Delta N, number of moles of gases product is greater than reactant, then passed. Then so NH3 gives rise N2 plus 3H2. Okay. Now this is a gaseous. This is gaseous. Delta N is equal to 3 plus 1, 4 minus 2 is equal to 2. So that delta N is greater than 0. Means delta H is equal to delta U plus, this is 2 now, 2 into RT. Means for this one, adding this factor, it is equals to this one. So that this is greater than this one. In this situation, delta H is greater than delta U. Right, children, different factors are there how to solve the delta H and delta U problems by using the bomb calorimeter. Okay, na? In different enthalpies. We'll discuss in the next class. Okay, how to solving the internal energy at a constant volume by using the bomb calorimeter and determination of the energy at open vessels dissolution process in bomb calorimeter too. So how we can solve this problem? Those discussions will be continued in the next class, children. So this is our class for today. Please, children, solve the problems up to enthalpy. Okay, no?
Thank you, sir.
So
Sir, slow down, sir.
scroll down now. So I am going to right.
Thank you.